Hi everyone, and welcome to the second part of the Radeon 9250 repair. It's not important, but if you haven't seen part 1 yet, I highly recommend that you watch it, as it details what state the card was in when I first received it, and shows how I cleaned it and reflowed the video memory. Reflowing the old memory chips didn't work, so I ordered some new memory from AliExpress. I had no idea if this memory was going to be real, or if it was going to be used. Spoiler, it was indeed used. But it ended up working out great anyway. Apologies for some of these clips not being in focus here. The first thing I have to do is remove these 4 capacitors, as I don't think they will survive the heat from the hot air station. I added some leaded solder to the capacitor legs. Then I try using my desoldering tool. However, this model doesn't quite get hot enough to melt non-leaded solder, at least not without a preheating station. So I remove them simply by heating the legs and gently pulling them out of the circuit board. I'm going to clear the through holes using a pin. Where the pin is pushed into the end of a piece of wood, here I am preheating the graphics card to about 40 degrees Celsius. It's not much, but it's all I have at the moment, and it does help if the board is pre-warmed. What I do here is put a little bit of leaded solder onto the through hole. Then I use the soldering iron to heat up the pin and push it through the hole. This pushes out the non-leaded solder and it gets stuck to the pin. I then use the desoldering tool to clean and suck the solder off the pin, and this clears the hole. I've been using this technique for a while now, and it's fast and effective. Here are the results of all the through holes being cleared using this technique. Out of curiosity, I decided to test each capacitor just to make sure that they are okay, and they all tested good. The next thing I do is put some Kapton tape on all the tiny resistors and capacitors that are around the memory chips. I do this on both sides of the card. This could be a little unnecessary, but I really don't want to have to reattach any of these tiny components today. Now I apply some no clean flux and add some leaded solder to the legs. This will help lower the mounting point and allow these chips to be removed easily. I don't have to worry about doing this to the back memory chips, as this has pretty much already been done during the reflow process I did in the last video. Next I apply some hot air all around the memory chip, and then use the end of a popsicle stick to gently feel when the chip starts to move. Then once I see that the solder has melted, I remove it by using some Kapton tape stuck to the other end of the popsicle stick. I didn't order a suction pen yet as I didn't think I would need one, as from what I've seen online they're mostly used for removing BGA chips. But after doing this job, I see that I definitely need to order one, as trying to use tweezers with these larger chips can make a real mess if you slip. I repeat this process for all the other memory chips. Now I gently remove the Kapton tape from around the board. Next I add some no clean flux and begin the cleanup process on all the pads. As you can see, some of the traces are squiggly here. Circuit board designers do this on purpose so that signals are timed and reach their destinations at the same time. Here I am using non-fluxed solder braid. This helps to keep things clean. I'm not pressing down too hard. I'm very gently moving the braid down as the solder melts and gets absorbed by the braid. Now I begin the process of cleaning up all the flux. I put some IPA on the pad areas and use some cotton wool to wipe up as much as I can. It's quite difficult to clean, so I add some more IPA and then change over to some cotton buds. This also helps to clean up some of the cotton wool that gets left behind. Next I inspect all of the pads under the microscope, just to make sure everything's okay. And I spot some little bits of copper left over from the solder braid. This one is even joining the two pads together, so I will have to remove these. I remove them by using some more flux and solder braid. Simply trying to use the soldering iron to remove it creates a high risk of ripping the pad completely off. And here are the results. The old memory chips have been removed. As you can see, the pads are nice and clean, and the old memory chips also look great. I then place one of the new memory chips down, move it into position with a toothpick, and hold it in place with my finger. I then tack it down in the upper right corner with a little solder. You can see that the two pins are joined, but right now this doesn't matter, and I will fix this later. I also do the same for the lower left corner of the chip. However, I decide to put it just to the left of the center, as I wasn't able to tack it down in the left-hand bottom corner because of the 0603 capacitor. I then apply some no clean flux to both the top and bottom of the chip pins. I apply some solder to the tip, then gently drag the tip along the pads, connecting the pins to the pads. I make sure that every pin has a solder join, and I also make sure that I remove any bridges crossing pins. I repeat the same process for the bottom and the top until the entire chip is soldered on. I repeat the same process for all 4 of the memory chips. Now I start an inspection process on all of the pins, and here you can see more signs that these chips were indeed repacks. As you can see, these pins are slightly bent, but I do end up fixing this. Next I go along with a pick tool and just see if I can feel where any loose pins might be. And I do actually find a couple that I fix up on the spot. Now I put some IPA around the areas where I put the flux, and begin the process of cleaning it all up using a small thick paintbrush. I repeat this on all 4 of the memory chips that I soldered on, until everything is nice and clean. I wanted to have a closer look at the legs from a side-on view, as so far I've only seen them from the top-down view, and what I find wasn't so great. Not only did these chips have bent pins sideways, they also had some that were bent upwards. So some of the pins didn't solder to the pads correctly. Off camera, I did mark out where some of these affected pins were located. So I go around the board with the soldering iron, and just push these pins down so that they make contact with the pads. In the future, if I discover that I have repackaged chips, I'll definitely place them down on a flat surface and just make sure all the pins are down evenly before I solder them on, because having this happen made the job take so much longer. It was at this point I decided to just go over some of the pins that looked like they didn't quite have enough solder between the pads and the pins. Then I start the cleaning process once again and get all the chips cleaned. Now things are looking really good. And here are the results so far. Everything appears to be soldered on correctly. The next step is to install the 4 capacitors that I had to remove. So one by one I place them in and solder them in place. I don't have any footage of this next part, but I do have this picture. What you're seeing right now is what I first saw when I plugged the card into the test bench board. The corruption seems to have disappeared. However, now there's some strange coloured lines running down the screen. I kind of just assumed that this whole thing was a failure at this point. But this is not where I give up. I decided to start checking every single connection, and to my surprise, I find 2 here that are not connected, so I mark its location, and then solder these 2 pins down correctly. There were also 2 pins on the other side that had the same situation, that I fixed but did not get footage of. And here are the final results. This is 100% done now. Every single pin is connected, and all the chips are 100% functional. I am now ready to do a proper test. Now it's time to test the card again using Knoppix. So I set up the test bench board and plug everything in, and this time I made a bootable USB copy of Knoppix. As you can see, the post screen looks great, and the Knoppix boot screen also looks good without any corruption. Now we enter the Knoppix desktop. We can see everything clearly, and there is absolutely no corruption. 3D acceleration also works. Now it's time to go and install it back in the Windows 98 machine I used last time. I install the card and press the power button. And as we can see, the Windows 98 logo has no corruption. This is a very good sign. The computer boots up into Windows and detects the graphics card. Without drivers, we can clearly see a huge improvement from the previous attempt. I get the drivers installed and reboot the system. Once the system has rebooted, the first thing I want to try is 3D Mark 2001, because the Radeon 9250 supports up to DirectX 8.1, and it should be able to run this no problem. And here we go, we are about to see what the system can really do. Oh, okay. It didn't work. I suspect that this could be a driver issue or a DirectX version issue, or the fact that this is a PCI card. I really don't know. I tried a few more times, and I wasn't able to get 3D Mark 2001 running on this system. Please let me know down in the comments if you have any ideas on why this might not be working. However, just because 3D Mark 2001 won't run, doesn't mean it won't run other games. I tried Unreal Tournament 2004, and this seems to run just fine at 800 by 600. I also tried System Shock 2, and this runs really well also. Then I fired up the original Half-Life 1, and apart from a slight jitter when I turned left and right, this game ran really well. And last but not least, Star Siege Tribes. This sure does bring back memories. I can remember playing this on dial-up with a friend, and we used to have so much fun playing with other players from all over the world. Okay, so this wraps up the video. Thank you for watching. I had a lot of fun repairing this card and learning stuff along the way. It feels so good to make something work that wasn't before. Until next time, take care everyone.